A uniform solid cone of height 0.8 meters and semi-vertical angle 60 degrees lies with its curved surface on a horizontal plane. The point P on the circumference of the base is in contact with the plane. V is the vertex of the cone and PQ is a diameter of its base. The weight of the cone is 550 newtons. A force of magnitude F newtons and line of action PQ is applied to the base of the cone, see figure 1. The cone topples about V without sliding. Calculate the least possible value of F. First, I am going to talk about the center of mass, S. In one dimension, it's halfway. In two dimensions, the distance of the center of mass and base is 1/3 of the height, it is here. And in three dimensions, the distance of the center of mass and base is 1/4 of the height, it is here. We'll use this because the cone is three-dimensional. Here is F, the weight, and actually here is the normal force. Its moment is 0. This is 1/4 of height, so it's 0.2. This is 0.6. It's 0.8 minus 0.2. We'll calculate x. Cosine of 60 degrees is equal to x over 0.6. This is 0.5, so it's x is equal to 0.3. We'll use that sum of the moment is 0. This is our positive direction. So F times 0.8 minus 550 times x is equal to 0. So F is equal to 206.25 newtons. The force of magnitude F newtons is removed, and an increasing force of magnitude T newtons acting upwards in the vertical plane of symmetry of the cone and perpendicular to PQ is applied to the cone at Q. See figure 2. The coefficient of friction between the cone and the horizontal plane is mu. Given that the cone slides before it topples about P, calculate the greatest possible value for mu. These are forces: weight T T normal force, and we should calculate some distance. First, y, this is y. We can apply cosine. Cosine 60 degrees is equal to 0.8 over y. So here is y. Then z. Tangent 60 degrees is equal to z over 0.8. Here is z. And before we have calculated this, so key1 is equal to y minus 0.3, so it's 1.3, and key 2 times z, it's equal to 2.77. We break down this t. This is perpendicular to the base, and this is 2, so this and this are parallel, and this line and this line is also parallel, are also parallel. So this is 60 degrees. This is adjacent of angle, so it's t times cosine 60 degrees. And this is t times sine of 60. These are positive directions, and here is the friction force 2, and the conditions of equilibrium. Sum of F is equal to 0, and sum of the moment is equal to 0, 2. Here is the x direction and y direction. Let's see, x direction, there are two forces, t times cosine 60 minus the friction force, it is here. In y direction there are t times sine of 60 n minus gravitational force, it is here, and there are two moments. The cone topples about P, so this is a T, we use now T, it has a positive moment, T times key 2, and negative the gravitational force. So it is here. We substitute key 1 and key 2, and we get that T is equal to 258 newtons. Next, we substitute this value here and calculate the normal force, it is here, and at last we substitute these values here. So we get that mu is equal to 0.395.